Hello everyone to the new course we offer in our engineering courses category. The title is Introduction to Digital Image and Video Processing. And as before, we encourage you, if you're interested in finding the historical journey of the words mentioned here, like digital, image, video, we encourage you to kindly visit Cambridge or similar quality websites in order to find out the details on the words, which will really help you understand the topic of interest you're attending. Okay, so let's carry on. So we offer these courses under Contact Field Institute, which is an affiliated organization with Soft Galaxy Technologies Inc. Anyone interested in connecting with us, kindly visit our LinkedIn profile and see what we have done, what we offer. You can also reach us by sending an email to info@HS stands for Humanity Serving Clouds.org or softgalaxy.hsclouds@gmail.com. As an organization, we firmly believe in this particular sentence, that there is no shortcut to glory, meaning that whatever area of interest you want to excel in, you have to follow the process of understanding the basics, practicing and achieving desired skills in order to be successful in that particular area of interest. So the course objectives are that to bring a clarity on the concepts relating to digital image and video processing. We will also give you hands-on skills required and relating to industrial knowledge, which will be greatly beneficial for you to use the techniques learned here in industrial and consumer applications. In the past, if you haven't seen these YouTube videos, please download the slide for which the link is given in the description. Download the slide, go to this link and watch these YouTube videos in its entirety without skipping, which will basically help you learn that how the industry is using image and video processing techniques benefiting their objectives. Like in the case of robots, I'm just going to give a brief overview here. In the case of robots, there are sensors, image or non-imaging sensors, but most of the time robots do have imaging sensors which detects their surroundings, and based on that images, the acquired knowledge because of image processing, image or video processing, they make their decisions of whatever they need to do. And this particular YouTube link shows really cool information on what we just described. Self-driving cars, obviously a lot of image and video processing, and similarly in Amazon's order fulfillment center, the use of robots and drones, they are basically using image and video processing along with other sensors technologies in order to achieve their objective of delivering customer orders to their destinations. Okay, let's carry on. So this is the marks distribution. If you have attended our course in the past, you know it's a pretty standard scheme we follow. But just for the new ones, assignments are 10%. Assignments do include the lab work which we will assign. So 10% includes lab work plus assignments we give during this lecture, or we will assign you as a separate document. So that 10% will be 5% before the midterm and 5% before the final exam. That's how the assignments will be given. The lab work will be 20%, and that 20% you will be tested on these assignments given to you. So it will be an hour-long exam before your midterm, and an hour-long another exam before your day of the final. Once you do your lab exam, you will be given a 30 minutes or 1 hour break before your actual midterm, which is 30%, an hour-long exam, and finals 40%, which is hour and a half long exam. We will go for industrial tours, helping our students see that how the acquired knowledge is utilized in the industry, is basically greatly benefiting them complete the circle, the knowledge circle of what they have learned and how it is utilized in the industry. Okay, so let's carry on. So here are the snippets we have taken from the reference book which we will follow for this particular course, and the reference of that book is given in the reference section at the end of these slides. So going through the introduction, we will go through the introduction of image and video processing. We will discuss the basic image processing techniques. You can see the topics under that: gray level image processing, binary image processing, so on and so forth. Then we talk about image and video enhancements and restoration techniques. And you can see there are a lot of topics in relating to that. We will try to cover the most important topics first, and if time persists, we will discuss other topics as well in a particular topic when we will be following this particular course. Because image and video processing or any other topic, there's so many topics one can discuss, but again, because of the limitation of time, we just want to make sure that the most important topics are covered and students understand that before moving to the subsequent topics. So image and video analysis, image representation and image models, image and video classification and segmentation. We will see in the subsequent slides some of the examples relating to both these. Edge and border detection, we will see the examples in the subsequent slides. Algorithms for image processing, we will discuss in this course. We will talk about image compression. Compression has greatly helped the amount of space required to save images or videos. So these are very important topics we will go through in this particular course. We will discuss image and video acquisition. What sensors, what parts, what processes are followed to do that. Image and video rendering and assessment we will discuss. Image and video storage, retrieval and communication. We will discuss and applications of image processing. You see those applications nowadays in almost everyday life, but we will give an overview and some technical insight to those applications. Okay, so when we talk about images, okay, so even videos are nothing more than collection of images rendered at a speed which our naked human eyes can't detect. So video is basically a collection of images played very fast in front of our eyes, which we will conceive as a video. So that's why when we talk about images, we are basically talking about electromagnetic spectrum. So that's a term which all of us have to really understand very well. So electromagnetic spectrum means the frequency of energy, you can say, the frequency of energy which we can see visible. So these wavelengths or frequency of energy is visible to human eyes. Anything on the left side or on the right side out of this black box we cannot see. Our human eyes cannot see because it's outside our ranges of visible spectrum. Okay, so but in its entirety, this is, you know, the energy or the wavelength can range from, you know, it's a huge range, and out of that huge range, only a very tiny portion is visible to a naked human eye. So in this particular course, we will be focusing on visible spectrum, but obviously we will discuss in detail, you know, how the other techniques like X-rays or MRIs or which are imaging techniques utilized, you know, how they work, the images, and they transform those into to images which are visible to our eyes. Okay. So remember, this wavelength over on this particular slide is shown as angstroms. This is a unit of wavelength, and we will discuss what an angstrom is, or what means by a wavelength and frequency. Most of them, if you have taken the basics in engineering courses, you already know about wavelength and frequency, but we will discuss the units associated as we go deep into the course. Okay, so this slide shows the recording the various type of interaction of radiation with matter. So what this image is trying to show, that there are different sources of radiations. The most common one that we know is sun. Okay, so this is an emitted radiation. We all know, you know, that's how our Earth. This is our Earth's main source of energy, but there are other radiation sources, you know, which emit radiations, and some of the objects, like in this case, it's an opaque reflective object. So what it does, it basically, whatever radiation strikes this object, it reflects it into all different directions. As you can see, there's arrows, but one of the reflections can come to a place where our sensor is. Okay, this can be a camera or any other type of a sensor. So this radiation is coming into and coming to this channel of this particular sensors containing device. In case of self-luminous object or a sun, emitted radiation is, you know, coming directly into this particular device containing sensors. And another radiation source which going through an opaque object, a transparent, sorry, not opaque, opaque is this one, I'm sorry for that. This is a transparent object, so another radiation source, the energy is passing through this transparent object and going directly into this device containing sensors. So we have received radiations from different sources. This is what this image is showing. The sensor detects those radiations and converts it into an electrical signal. If you have taken our course on sensors and systems, we have discussed in detail different sensors and paths, how that conversion process happens. If not, but in this course, just simply understand this, that there are sensors whose primary job is nothing more than to convert the acquired signal into an electrical signal for further processing. Okay, so once we have this signal, from this signal we make our decisions relating to imaging and video processing, and we will learn in detail how we do that in this particular course. Like over here, this is a continuous signal. Okay, a continuous signal is basically an analog signal, and sampling this analog signal is part of the process. Sampling means using an analog to digital converter or some digitization device, and this is this particular graph is showing that that we have sampled this analog signal, and this is a visual representation of sampling. That if, for example, the acquired image is of 26 by 20 256 by 256 resolution, pixel resolution of image. As you can see, we can clearly identify that what an object is, what it looks like. But as we reduce our sampling to 128 by 128 pixels, you see that the information, the quality of information gets diminished. Okay, like in the case of 64 by 64 pixels, as you can see here, it's very difficult by a naked eye to clearly see the detailed features, as is the case in 256 by 256 pixel image. And here's the fingerprints or of a human. You can clearly see the details on a 256 by 256 pixels image compared to other low resolution images. So that's why it's very important to acquire an image at a higher resolution in order to have the desired quality for further processing. So this is basically showing that rather than simply using a single pixel for image acquisition, it will be better to have multiple bits. This is an 8-bit representation of a single pixel on an image rather than a simple pixel, because it gives us the detail required on the acquired image, and that's how we achieve the required quality in an image. It can be 8-bit or higher rather than a simple using a single pixel is good as long as it's a simple grayscale, not a grayscale, like a simple image which doesn't require that kind of the resolution in bits. It may be useful in some applications, but most of the time, since nowadays because of the cost is quite low, so we go with using multiple bits when we're trying to acquire an image rather than using a single pixel. Historically, since the cost was a big concern, so that's why it was carefully selected that what type of a sensor can be useful for a given application. Not the case in 2023. So this basically shows that the processes involved in image processing. So we acquire the image using image sensor, and it can take one of the two paths depending on a particular product or a process. You can convert into a gray level image, or you can remove the noise in the image first. Both can come to this route for edge detection, or they go for image segmentation, and from the gray level image it can go to image enhancement, and we will see in our next few slides what means by gray level image enhancement, segmentation, or edge detection, or noise removal as examples. But we will learn in this course in detail about how these features are implemented and achieved. So this is for medical image processing. The processes, they look into, they try to follow. So this is the formation block where they acquire and digitize, and this is the enhancement block. As you see, the enhancement is there's so many other processes involved in image enhancements: calibration, registration, optimization, transformation, filtering, and here the visualization block, the analysis block, and the management block. And we will discuss, when we talk about medical image processing, we will discuss the commonly used processes in acquiring a desired information from a digitized image. Again, a similar, kind of a process or something similar: acquisition, pre-processing, segmentation, feature extraction, and classification. So here's the visual practical examples of what we just mentioned. As you can see here, here's an actual image, and this is a segment edge detected image. So an original image, edge detection, original image, edge detection, and these are the edge detection of an image of an owl, a fish, human faces. Okay, so basically we're trying to extract information from an image for desired purposes for further processing. In this case, in this particular slide, it's all about detecting edges. Okay, and this is the example of image enhancements. As you can see, out of focus image, because of the techniques we employ, pretty focused, out of focus, pretty much focus, out of focus, pretty clear, and again kind of a blurry image, and we enhanced using morphological operators. As you can see here, pretty clear image. So correcting non-uniform illumination with morphological operators, and we will learn about all these techniques during this particular course. Another example, so this is a street with a lot of people, cars, bicycles, and as you can see here, the techniques employed by image and video processing, every object is properly classified. So see, this is a car, this is a person, this is a backpack, you can see this is a bicycle, backpack, a person, if they see, this is a traffic light. What else we can see here? So what I'm trying to show here is that nowadays these techniques and knowledge in image and video processing has brought us to what you see here in this image, that they can quickly classify objects in a given image, and that is amazing, because that leads to many useful humanity-serving applications, and we will discuss in detail during this course that how such things or such techniques are developed and how they work to achieve desired objectives. Again, original image and image classification. As you can see here, different colors to different object in the image. So that was the original image we saw before in the slide, and this is what we discussed in our previous slide, image classification. But we're removing the boxes and the labels by just having, you can see from the colors that how the image processing algorithm has worked and accurately identified different objects in a given image. And this is an example in medical imaging. As you can see, it's an original image of a heart, and different edge detection or feature extraction processed image of a human heart, original image, MRI or whatever scan, and you can extract to see only bones or bones combined with different sections you want to see in that image. So that is very powerful for a physician to have these features, rather than trying to just look into this image and try to a lot of time and effort goes into analyzing an image like this to extract required information to make correct decisions. Having the ability to do things like this is a great benefit for physicians in making right decisions in their practices. So similar here, as you can see, it's an MR recording, pre-processing, kidney localization, and here you can see the kidneys are localized and identified and properly colored edges appear. That's really powerful. It's an original brain image, and this is a filtered. You can compare the clarity it brings in because of digital image processing, and we will discuss all that in this particular coursework. In this course, we will be using MATLAB for image processing, image and video processing, but alongside MATLAB, I'm sorry for that, alongside MATLAB we will also, as time persists, and we'll use this scikit because it uses Python. So it's scikit for image processing. Python is very popular globally nowadays because of its ease of use. So we will emphasize using MATLAB and scikit in this particular coursework for labs and miscellaneous tasks. If time persists, we will look into other tools as well, like Scilab or OpenCV. But again, time persistent, dependent. But we encourage students, that if you have time to explore other tools as well in your own time space. So this is a reference. We are following the Handbook of Image and Video Processing. A lot of information written by so many quality authors. So this is the book we will be following, but we are not limiting to only this particular reference. Students are encouraged to follow the slides, listen to all the information, take notes, and ask a lot of questions in the Q&A sessions to bring clarity and be able to acquire the required ability to perform good in your exams. Okay, so I hope to see you in our subsequent lectures. Thank you. Take care.